Hello. Am I audible? Hello. Can you hear me? Hello. Am I audible? Anybody? I'm confirmed. Hello. Can you hear me? Anybody? Can confirm? Yes, we can hear you. You can unmute yourself and confirm to me.
Yes, you are audible.
Hello. So, good evening to all of you. Myself, Prasad Khanna, I will be taking the session for today. Okay. So, if you have any doubt, so you can unmute yourself. You can raise your hand and accordingly we can take. Okay. So, meanwhile, have you covered the lectures video? Anybody who have covered all the lecture video? Yes, no. Okay, so how many lectures you have covered? You can unmute yourself if you want. Okay.
So like I have done 80 videos something
Okay.
for statistics.
Which topic you are studying now?
Sir, currently I have completed the conditional probability one.
Conditional probability. Okay, okay. Okay. What about others? Okay, so just keep a pen and paper ready with you. What we'll do, I have collected some questions. Uh, I mean, related every topics from week one and week two. So what we'll do, we'll go through that questions and along with that questions, we'll discuss the related topic. Okay, will that be okay for everyone?
Yes.
Okay, yeah, yeah, great, great. Okay, so let me share my screen. Is my screen visible to all of you?
Yes, sir.
Okay, so let's start from the week one itself. Okay, so I have collected some questions from week one and week two. Let's do it first itself and then we'll move to next. Okay, so anyone can tell me, okay, so you had studied about sample population and all, right? So first question I have selected. So it says which of the following statement best describe the difference between the population and the sample. Okay, so you have four options. Okay? So which option should be correct? Okay, you can take 1 and 2 minutes and tell me the answer.
The
So
following
first,
time breaks the different meaning of living and measurement rule of beginning is answer of the sample, which is usually
sorry, can
more
you
prevalent.
speak
Sample
aloud?
and prevalence is run the predictions and time and success. Describe the parameters of the government.
Okay. So this is the basic key about basic thing for statistics. You must know what is the meaning of sample, what is the meaning of population. So you guys will tell me which option should be correct.
See,
Sir, C.
C. Okay, so I got two votes for option number C. Anybody, any option?
see, sir.
C. Why is that? Why not option A? Why option A is wrong?
Sir, in it is like a sample is the entire group, which is not true
Not true, right?
because
So
yeah.
basically, population is the entire group, while the sample is a subset of the population, which is used to describe the parameters of the population. So basically, there is concept of population and sample. Okay. So what population says basically? Anybody can tell me? So population nothing but the total collection of all the elements that we are interested in. That's all, right? Is it or not? So it's nothing but total collection of all the elements that we are interested in. That's called the population. Correct or not? So, for example, let's say I'm interested to know the percentage of all students throughout the India, right? So, what will be the population? Population will be, let's say, throughout the India of class 12th student. So, population is what? Population is the all the students who are studying the class 12 in that particular year, correct? So that is something population. It's nothing but total collection of all the elements in which we are interested in. So basically population you can say like this. So population is a bigger set, right? Suppose this is the population. Okay, let's say these all are class 12th students from throughout the India. Okay, now what sample says? Sample says is nothing but sample is the subset of the population. Okay, so sample is nothing but sub part of this population. That's all. Suppose you have selected some 300, 500 students of class 12 from various regions or various states of India. So those students will be considered as a sample. Okay, so this is treated as sample, which is nothing but subset of your population, and this is the population. So basically, population is called nothing but collection of all the elements in which we are interested. Okay, is this clear to everyone?
Yes.
So yeah, so option C is the correct option. Okay, so next question says, yeah, a study has been conducted to examine whether the students who had applied for MA Triple A exam entrance exam in 2020. Now, from where you have to identify. So question says, in 2020 are willing to write the exam in the coming week or not. A group of 10,000 students are randomly selected from the urban areas of India for this study. It is concluded that roughly 80% of the students want to write the exam. So based on this information, you have to answer question number 2, 3, and 4. So first question says you have to identify what is the sample and what is the population. Okay. So by saying the question, tell me which option should be correct. Either option A should be correct, or B, or C, or D. So did you get the question right?
Option B and D.
Option B and D. Only one option is the correct. Okay, you are saying option B and D. Let's wait for others.
Option B.
Option B. Okay, I got 2 votes for the option number B. Anybody else? Rest of the people have someone has written option C, option D.
I think
Okay,
it
so
should be.
okay, it should be D. Okay. Yeah, so D is the correct. Why option B? Why option B? See, if you see in the question, it is clearly written that, it is clearly mentioned that a group of 10,000 students were randomly selected from the urban areas of the India for this study. Okay. So basically what has been done here, so they have done like, this is the total population, right? Correct? Total students across all the India. Now, so what the sample they have taken, they have selected 10,000 students from the urban areas of the India. So this 10,000 is the nothing but sample one, correct? And this is the population. So population will be students from all across India, and sample will be your 10,000 students, which are those are selected from the urban areas of the India, correct? So option D is the correct, not option B. Option B, in the option B, it is not mentioned how many students we have selected, but in the question it is clearly mentioned in the sample we have selected 10,000 students. Okay, is it clear why option D is the correct one?
Yes, sir.
Okay, yeah. So now, so this is the information about question, right? So this, just a minute. Yeah. So next question is based on the previous information also. So next question says identify the correct statement from the following. So first statement says aforementioned conclusion made on the basis of the sample is correct. Aforementioned conclusion is not correct because the sample is not a good representation of the population. The sample is a good representation of the population. Okay. So you tell me which option should be correct. B. Which option? B.
Yes.
Sub D.
Okay. Okay. I got 2 votes for B. Why B? Can you tell me?
Because from the urban population, the sample has been selected, not from the all the.
Correct. Great. Actually, the sample which we are selecting, right, in general. So sample should be a good representative of my population actually. So what is the meaning of good representative? So basically, see, if you see here in this question, what we are doing. So this is, suppose this is a population, right? Students across all the India. So in the throughout the population, suppose this is urban area, right? And this is a rural area, correct? Just assume. So what we are doing in our sample, we have selected only from the urban area, these 10,000 students. So this sample is not a good representative. So it will be good representative if we are saying we have selected 10,000 students randomly from urban area as well as rural area, from both. Okay. Then our sample will be the good representative. So for this particular question, your sample is not a good representative for my population. Is this clear to everyone?
Yes.
Yes, sir.
Okay. So for example, let's take another example. Suppose in a college, let's say you want to know the average marks of the student from throughout the various departments, right? So but suppose in that particular college there are 4 departments. First one is, let's say, English, Department of English, Department of Mathematics, and Department of let's say Science, and let's say Department of some uh, some humanities and all, right? So now what? Suppose you came to that college and you have selected the sample to know the average marks of throughout the college. You have selected the sample of 200 students from English department, let's say. Okay. So whether your sample will be good representative or not?
Not.
No, right? Because you have done the selection of sample only from English department, which is not a good representative of your population. So good representative of population means you are randomly selected, let's say 200 students. Suppose some students from English, some students from mathematics, some students from science, some students from humanities department, right? So that is the something meaning of the good representative. Okay. One more thing. So next question is, what can you say about the nature of the study? Whether a study is descriptive or inferential, which option should be correct? So let me go to the question. So this is the question. So by reading the question, tell me whether this the study which has been done, it's a descriptive or inferential statistics.
It's descriptive.
Okay, I got one answer, descriptive.
Descriptive.
Okay, again descriptive plus one. Anybody else? So you are writing on B. What is the meaning of B? Inferential you are referring?
Yes.
Okay, so someone says descriptive and someone says inferential. So why descriptive, anybody, and why inferential? I wanted to know your thoughts for the same.
We wanted to infer from the some population. So that's why I thought about inferent.
Okay. And what is the descriptive statistics in general, basically? What we are doing in descriptive statistics? So descriptive, let me clarify this. So descriptive in descriptive statistics, in this part of statistics, what we are doing, we are describing our data. Okay. Normally we are describing or summarizing our data set actually. Okay. So what is the meaning of describing and summarizing your data set? So basically I can say you can say simply to sum up the main points of my data set. Okay. So like what you can do, what you can describe, what kind of meaning of summarizing your data set. Let's say whatever data set you have. Okay. So you can take what kind of thing you can describe for your data set. I can tell, let's say, what is the maximum value, correct? What is the minimum value? What is the mean, right? I can plot bar chart, anything, something like that, right? Basically. So basic descriptive statistics means we are describing the data set, whatever I have data set, that's all. Suppose I have data set, let's say marks of a student. Okay. Marks of a student of class 10th, let's say. So I have, let's say, marks 42. So these all are marks out of 100, let's say. Let's say these all are marks. Okay. Suppose these are the marks of 5 students. Okay. So suppose this is the data set you have. So what is the meaning of descriptive statistics you can take? So you can take you can tell the what is the minimum marks, what is the maximum marks, what is the average of the marks. You can plot the bar chart and all, right? So that's all. Not more than that. So basically we are describing my data set. We are telling something about my data set. That's all about descriptive statistics. Now comes to the inferential statistics. Okay. So now tell me from here onwards, so whether descriptive statistics can be performed on sample as well as population or not?
Yes, sir, it can be.
It can be, because descriptive statistics is nothing but we have to describe my data set, right? We have to give some summary of my data set, right? So that can be done on any data set, right? So descriptive statistics can be performed on population data set as well as sample data set, right? Now come to the meaning of inferential statistics. So by the term, it's clear. Inferential means we are making some inference, right? So basically inferential statistics means we have to draw the conclusions for my sample, for my population based on the sample data. Okay. So inferential statistics, nothing but includes drawing the conclusions based on sample data for my population data, right? So this is something called inferential statistics. So basically, what's the inferential statistics? Let's say, suppose you went to a school, okay, and you wanted to know the average marks of class 10th student, okay, or you can say average marks of, on an average marks of the students. What is the average marks of a student in that particular school? Let's say. So what will be the population basically? All students in that school, right? Correct? Correct or not? Yes, no? Okay. So what will be a sample? Suppose you have selected some 200 students randomly from the school, right? That 200 student can be of from the class 10, class 12, 12, class 8. I mean, overall, you wanted to know the average marks of that particular school, right? So now you have selected 200 students randomly from the school. Now, suppose you have calculated the average marks of these 200 students. Okay. Suppose this is coming out to be, let's say, 72. Okay. So far, so good. So what we are doing, suppose if after this you are making the conclusion for the population that average marks of in that school, let's say school ABC, average marks of the student in school ABC is 72. So that's called the inferential statistics. So what we are doing based on the sample data, we are not going to perform on the population data. Based on the sample data, we have done something. After that, I'm making the inference or I'm making some conclusion for my population data set. So that's called the inferential statistics. Is it clear? Meaning of inferential and descriptive?
Yes,
Yeah.
sir.
Yes.
Okay. So the same thing, if you see in the question part, in the question part, what they are saying, so they have selected the 10,000 student, right? So after that, it is concluded that roughly 80% of the students want to write the exam. So what they have done, based on these 10,000 students, they have made the conclusion about, they have made the conclusion that roughly 80% of the students are going to, I mean, they wanted to write the exam, correct? So now tell me, what is this? So this is inferential statistics, right? Based on the sample data, we are making the some conclusions, some inference throughout the, I mean, for all the students who are going to apply for MA Triple E exam. Is this clear to everyone?
Yes, sir.
Okay.
Yes, sir.
So correct answer is the inferential statistics. Okay. Now,
Yeah.
okay, is this clear so far? Can we move to further
Yes.
topic? Okay. Yeah.
Yes.
Okay, great. So next question is it visible, clearly visible to all of you, right? So
Yes,
question
sir.
says, Karthik wants to start a soup production company for all the Indian market. To analyze public preferences, he hires a team of market researchers who conduct the market research in two states. Let's say that two states are Andhra Pradesh and Maharashtra. The market research team prepares a form to collect the data and collected the data in the shown in this table. So based on this information, you have to answer the question. Okay. So this is the table. So first column says it's included the name. So first is the serial number. So serial number is just index. It's not it's not a variable actually. So name, another is age, and then sum material, then purpose, then price range, then suggestion. Okay. So fifth question says, which of the data collected data is unstructured? So options are name, sum material, price range, and suggestions. Okay. So tell me, by seeing the table, which is the unstructured?
Suggestions.
Okay. Why not others?
Suggestion.
Why not others?
So all others are like well structured because some of them are like
Okay.
having
Yeah.
categorical data and all other things.
Okay.
It is
Anybody
in
else?
some constraint.
Okay. So anyone of can tell me what is the structured data and unstructured data? What do you understand the meaning of structured? And feel free to say. Don't worry, it will be wrong and all. Don't worry. So things are we can discuss it. Okay.
Maybe a structured data has a schema.
Structured data is
Schema.
okay.
We have the schema.
We know
difference.
all the labels associated with it, like
Basically, yeah, correct, correct. So basically, structured data is something, I can say it's a clearly defined and searchable type of data, right? It's a predefined manner already, right? So can I say such? So structured data are something that are clearly defined.
Yeah.
Okay, and I can say it's a searchable kind of data, right? So you
Yes.
can easily search the things, right? You can easily analyze the things, right? And it's always in a predefined manner, in a standard manner. Okay, so that is something we can treat as a structured data. What's the meaning of unstructured data? So unstructured data is nothing but it's so by seeing the unstructured data, you can't basically you can't analyze the things very easily. Okay, basically it requires more work to understand the data. And it's not in any predefined manner. Okay, so what is the meaning? Now if you see, let me give you one example. Suppose I'm going to make a table. Okay, and I'm saying if you're going to that let's just okay, suppose I'm saying this is the name of the student. Let's say this is the class, this is the state, and let's say this is the mobile number. Okay, so suppose I'm saying name of a student, let's say Shivam. Okay, and let's say class is 10th, state say let's say Delhi, and mobile number is let's say 9328, something like that. Another student, let's say Suman, class is 12, and let's say state is Haryana, mobile number is let's say 72, something like that. Another student you can take name is Prateek, something. Class is 10, and the state is let's say uh, Bihar, and mobile number is let's say 6932, something like that. And let's say another is Ram, let's say 9th, and let's say Tamil Nadu, and their mobile number is 78 something. Okay, suppose so what kind of this data is? Suppose you are seeing this data. This is something structured data.
Yes.
So it's already in predefined manner, right? Suppose I asked you, tell me the mobile number of Pratik, right? So you can easily tell me the mobile number of Pratik, right? It's a easily searchable data, right? These all are in a predefined manner, in a standard form, correct? Suppose I ask to tell me the Ram state of the Ram. So you can easily tell me he's from the Tamil Nadu, correct? Suppose rather than this, suppose you have data like this. I'm saying let's say Shivam is like say, let's say let me write in some native format. Shivam is a student of class 10. He is from Delhi, and his phone number is something like that. And next, let's say Suman is a student of class 12. Okay, something like that. It's a written. Okay, so now I ask, tell me the mobile number of Suman. So whether it's you can easily tell me the, will you able to easily tell me the mobile number of Suman?
No.
No, it requires some more effort, more work to analyze, right? Because it's not in any predefined manner, it's not in any standard format, right? So that's something called the unstructured data. So by terminology, I think it is clear what is the meaning of structured and unstructured. So here, as you can see, price range is what? It's in standard format, whether it's a high, medium, low, let's say shoe material and all. But suggestion is something which you cannot put in a particular manner, right? It can be anything, right? So here,
Yes.
suggestions is the unstructured data. Suggestions will be considered as the unstructured data. Okay. Now, next option is which of the following each oblique R means it's a MSQ. One or more than one can be correct. Are cases or observations for your given data set. Okay. So tell me. Okay. So should I go to the table? So you can, so options are name, Satya, Mayur, plastic, and formal. So options are, I'm writing the options are name, Mayur, Satya, plastic, and formal. So tell me which are the cases or observations.
Plastic and formal.
For plastic and
Formal.
okay.
Mayur and Satya are the cases.
Okay, someone says Mayur and Satya, someone said plastic and formal. Okay. Anybody else? So, okay. So basically, option B and C is the correct. Mayur and Satya is the cases or observations. Why is that so? Anybody? Cases is what? So
Cases are
basically,
the
cases,
knowledge
yeah,
that,
cases or
data
observation is
points are
nothing
recorded.
but it's a unit for which, from which our data is collected. Okay. So for this, we are collecting our data set. And one more thing, row represent the cases. Okay. So name is not a case. Name is the variable actually, because you can see it varies, right? Names are varying, right? So cases is nothing but it's a unit from which data is collected. So now you can see, and row represent the cases. Okay, and column represent the variables. So why variables? Because variables means values are varying under that column. So as you can see, for name, values are varying, right? For age is a variable. For this, you can say values are varying. Correct or not? So shoe material is a variable. Purpose is a variable. Price range is a variable. Similarly. So now, what is the case here? So case, and one more important thing, cases should be unique. Okay. So as you can see, and it's a nothing but unit from which data is collected. So this is the Satya. As you can see, Satya. First of all, this row represent the case, right? So this is the row or not? Correct. Similarly, Mayur is the row or not? It's a row, right? So basically, and you can see there is no repetition of Satya and Mayur. These all names are unique. So this is the unit from which our data is collected. Means for Satya, what is the age of Satya? What is the shoe material he is preferring? For what purpose he is taking? And what is the price range of Satya, right? Similarly, for Mayur, what is his age? What kind of shoe material he is preferring? For what kind of purpose? Similarly, what is the price range? So for this Mayur, we have collected data. Yes or no? So basically, cases and observation nothing but a unit from which our data is collected. And one important thing, row represents the cases. Okay, and you can see all are unique. No one is repeating. Okay, but here you can see high, medium, and all. So here you can say high is repeating, medium is repeating, right? In this throughout the column. So basically, what is the meaning of unique here? Suppose I asked to you, tell me the tell me the name of candidate who has the price range of high, right? So high is repeating, but here you are not sure. You can't say anything with surety. For whether I'm talking about Rahul because he's also preferring high price range, or whether I'm talking about Ashish, or whether I'm talking about, we are not sure, right? Simply suppose I ask about, tell me the name of the candidate who is preferring the price range, price range as the medium. So you are not sure whether I'm talking about Joseph or whether I'm talking about Chris or Yamini and all, right? So what is the meaning of unique? Suppose I told you, I asked you, tell me the purpose of let's say Chris, which for what purpose Chris has purchased the Sue and all. Okay, so you can easily see Chris is the unique element in this column, right? And you can easily tell me his purpose for that Sue is running purpose, right? Is this clear? Meaning of cases and observation to everyone?
Yes, sir.
So B and C will be the correct. Now, how many variables from the collected survey data are categorical? Okay, so you have to tell me how many data variables are categorical variables here. Anybody? How many variables are categorical here?
3, sir.
3. Okay. Why 3?
So show material, purpose, and price range would categorize the cases.
Okay. Anybody else? Only 3 variables?
I think it will be 4.
What are the names?
Name, show material, purpose, price.
Correct. So there are 4 categorical variables, right? So what is the
Yeah.
categorical variable? First of all, so categorical variable is always in qualitative nature, right? And main important thing, we cannot perform
Arithmetical.
any arithmetic operation on it, right? So that's called the categorical variable. If we are able to perform any arithmetic operation, that's we can treat as a numerical variable. So here you can see, can you perform any kind of arithmetic operation on the name variable? No, you can't say Rahul plus Joseph equal to Satya, or Rahul is greater than Joseph, something like that. We can't do, right? Similarly, for the Sue material, can we do? Can we perform any arithmetic operation? Yes, no?
No.
No, right? Similarly, we cannot perform any arithmetic operation on purpose. Similarly, for the price range. So, but we are able to perform the arithmetic operation on age. So, age is the numerical variable here, right? You can find the average age, you can find the maximum age, something like that. You can find the difference between age and all, right? So, we have 4 categorical variables in our data. Is this clear, everyone?
Yes.
Are you able to relate with the question, right? Yes, no?
Yes.
Yes, sir.
Yeah, great. So you can let me know, right, whether are you getting or not. Now, so next question is, in order to forecast tomorrow's temperature in Mumbai, the Indian Meteorological Department collects the temperature, humidity, and rainfall data for Mumbai for all days from the past 3 months. So what kind of data is this? Whether it's the time series data or cross-sectional data?
Time series.
Time series data.
Time series.
Okay, why is this time series? Why not cross-sectional? I got 2 votes for the time series data. Hey, you told me time series. Why is that time series? See,
Because it recorded for the same location.
same location. Is this correct reason or something else? Time series data is the correct option. Why? You should be aware about the reason, right?
Time is a dependent variable in this case, I think. That's the reason.
Basically, time series data is nothing but the data which you are recording over the different period of time. Okay. So time series data is nothing but data which you are data recorded over the time, right? And cross-sectional data is nothing but data observed at the same time. Okay. So here, as you can see, what that department has done. So they have collected the data for past 3 months for all the days, right? So data has been recorded over the different time, right? I mean, places is the same, but time is different. Data has been recorded for different time. So that's why it's a time series data. Okay. So basically, let's take this example itself, temperature example. Suppose someone wants to know the temperature of Mumbai for all the 7 days, right? For a 1 week. So suppose he or she is interested to know what is the temperature on Sunday, Monday, right? Tuesday, Wednesday, Thursday, and all in Mumbai city itself. So suppose on Sunday it's X degree Celsius temperature, on Monday it was Y degree, Z degree, and all like that. So what the he or she is doing? So she is recording the data over the time, Monday, Tuesday, Wednesday, and all, right, and so on. And place is the same. And what is the cross-sectional data basically? Cross-sectional data, time is the same, but places are the different. Let's say that person is interested to know the temperature on Sunday on different cities. Let's say Mumbai, Chennai, no, Pune, Delhi, like that. So what here you can see time is the same, right? But places are the different. So that's something called the cross-sectional data. Okay, it is clear.
Yes, sir.
Okay. Now, so let's move to the next question. A courier service is interested to knowing the customer feedback. The customers are being given the following options to choose from: not satisfied, somewhat unsatisfied, neutral, very satisfied, satisfied, and all. So what scale of measurement has been used here?
Sir, ordinal.
Ordinal, sir.
Okay. So ordinal is the correct. Why?
Here the data are in rank order, sir.
Rank, right? So
Yes,
basically, yeah, here data is something you can rank. I mean, you can say not satisfied, right? Then satisfied, then neutral, then satisfied, then not satisfied, somewhat, unsatisfied, neutral, satisfied, and very satisfied. So I can make the rank, right? I can rank this data set. So this is called something ordinal scale of measurement. Any one of you can tell me what is the nominal scale of measurement and interval ratio?
So nominal does not have any kind of ranking thing, and interval is something that does not have actual zero.
Okay. So basically, how many data? What kind of data we have? Categorical and numerical, right? So categorical is something on which I can perform I cannot perform any meaningful mathematical operation, right? And on the numerical data, we can perform meaningful mathematical operation. So we have four kind of scale of measurement. So for categorical data, I can use nominal scale of measurement and ordinal scale of measurement, while for the numerical data, I can use interval scale of measurement and ratio scale of measurement. Okay. So basically nominal and ordinal is okay. Suppose in any question it has been asked whether it's a nominal, ordinal, interval, ratio. First thing is just check whether it's a categorical and numerical, right? Accordingly you can proceed. So basically what is the nominal basically? So nominal scale of measurement is using we are using for the categorical data set. So in nominal scale of measurement, what we are doing, we are just labeling the things, right? We cannot order. We can label, but cannot order, right? So like what kind of example can be? Let's say name of a person, okay? Or let's say gender. So like that. So basically name we cannot order, right? But name is a categorical verb. You can't say like Shivam is greater than Shivani, or Pratik is greater than Ram, and all, right? We cannot any, we cannot make any order between, right? Similarly, gender, you can't say like female is greater than male or male is greater than female, anything. I mean, we are not able to make any order. So for those kind of variable, nominal scale of measurement is useful. Okay, is this clear? Nominal is clear.
Yes, clear.
So, and also you can code the things. I mean, let's say you can code it like female as 1 and male as 0. But there is not a meaning, any meaning of this 1 and 0. It's just a labeling, right? You can label the things, right? Now, ordinal means I can label, but I can rank also. For example, anybody? Any example for ordinary scale of measurement?
Low, medium, and high.
Sorry, low, medium,
And high.
yeah. Let's say t-shirt sizes. Okay. So for the t-shirt sizes, it can be small, right? Medium, large, XL, like that, right? So ordinal data is something, it's a name categories. You can label the things as well as you can rank the things. Let's say a rating of a food quality in a restaurant. You can, how you can rate? You can rate as poor, good, average, excellent, like that. Okay. So nominal and ordinal two is clear to everyone.
Yes, sir.
Okay. Let's come to the interval scale of measurement. So as we have done discussed, interval scale of measurements we are using for the numerical data set, right? So interval scale of measurement, in short, I can say it's a numerical values, okay, that can be added or subtracted. Okay, no multiplication, no division. Why? Due to no absolute zero property. So this is a very important key things in case of interval scale of measurement and ratio scale of measurement. Any one of you can tell me what do you understand by the meaning of no absolute zero or meaning of the absolute zero? What do you understand by meaning of absolute zero? No one? So absolute zero means, suppose I'm saying something about absolute zero means, it's a simple means absence of that particular thing. That is the meaning of absolute zero. Means absence of that particular. Let's say I'm saying zero number of person in a room. That means there is no person. Zero number of pen in a pen box. That means there is no pen, right? Like that. Absence of that book, that particular thing. So that is the meaning of absolute zero. But in case of interval, this absolute zero property is absent. Means let's say I'm saying 0 degrees Celsius temperature. So does this mean there is absence of temperature?
No, sir.
Right? We can't say there is no temperature, right? We can't say there is no temperature. There is still temperature, right? There is a meaning of -1 degree Celsius temperature, -2 degrees Celsius temperature, like that, correct? So in case of interval scale of measurement, this absolute zero property is not fulfilled. Okay, this absolute zero property is absent, and due to this, we are not able to perform multiplication and division property. Okay, let's say, okay, tell me one more thing that will be clear to you. I think -273 degrees is the lower limit, right? In case of Celsius. Correct me if I'm wrong. So suppose 0 is somewhat here, and suppose this is the 20 degrees Celsius. Okay, and suppose this is the 40 degrees Celsius, and this is the maximum. So can I say, okay, suppose distance from this to 20 degrees Celsius is A, and distance from this to 40 degrees Celsius is B. So can I say B is the 2 times of A? Yes or no? B is the twice of A.
No, I think.
No,
We
No,
can't say,
sir.
right? We can't say
No.
because absence of this absolute zero property, right? You can't say the amount of temperature from minus 273 to 20, right, is half of the amount of temperature minus 273 to 40. Correct? We can't say. So so from here we can't, but we can we can say something about addition and subtraction. That means we can tell about the difference of the temperature. We can't tell about something multiplication or division about temperature and all, right? In case of interval scale of measurement. Now, I will give you one example that will be clarify. Let's consider that ratio first. So in ratio scale of measurement, we can perform addition, subtraction, and multiplication and division because of there is absolute zero property. Okay, absolute zero property is present in case of ratio scale of measurement. Let's say, suppose I'm saying this is the minimum 0 marks in a class and maximum marks is a 100. Suppose someone student got 20 marks and one student got the 40 marks. Let's say this is the 100, like that. So suppose A got 20 marks, okay, and B got 40 marks. So now can I say B is the twice of A?
Yes.
Yes.
Yes, sir.
I will be right? I say,
Yes,
right?
sir.
Why? Because
right.
of this 0, right? Because of this 0, I can simply say B is equal to 2 times of A, or A got the half marks than B. Correct or not? So did you get the idea why? What is the meaning of what is the importance of this absolute 0? So here multiplication and division is I mean these two operations plus along with addition and subtraction I can perform in case of ratio scale of measurement, but I can't perform these things in case of interval scale of measurement. Okay. Is this clear? Is it okay
Yes,
for
sir.
everyone? Okay. In case of okay, so what about Kelvin? Temperature in Kelvin, whether it will have a ratio scale of measurement or interval scale of measurement.
So I think it's a ratio because there's 0 Kelvin temperature when there's
Correct. And
absolutely
0 degree Kelvin means no temperature, right?
yes, sir.
Okay. So, but yeah. So for temperature in Kelvin have the ratio scale of measurement, while for Fahrenheit and Celsius it has interval scale of measurement. Okay. It is clear to everyone? All the scale of measurement and all? Yes, no?
I didn't get why we called that ratio scale measurement.
Why we called ratio scale of measurement?
Why the name is by name of that is ratio scale.
Okay. So suppose just a simple thing. If I'm saying B is equal to 2 times A, can I find B of A equal to 2 by 1?
Yes, yes.
Got it?
Got it.
So I think we have covered the concepts of week 1. Let's move to the week 2. So whether do you want to discuss the concept or should we move with only the questions
Sir, we will discuss the concepts, sir.
along with, right? So I have taken
Yeah.
the questions. So along with that questions, we'll discuss the related concept and we'll move, right?
Yes, sir, sure.
Okay, yeah, sure. So this is the one question I have taken from related to the one of the concept of week 2. So this is saying number of days, the relative frequency is given to you. So first question, it has been asked how many deaths happened in the city in 2019. That means you have to find out the total number of death in 2019 in that in the cities. Okay. So I will give you 2 to 3 minutes. Will that be okay? Just let me know what is the answer. Okay? Hello. Someone got the answer? What is the correct answer?
Yes, yes, 1000.
1000. Anybody else? So 1000 is the answer, right?
Yes.
Okay. So what is the basically relative frequency? Anybody of any observation? So relative frequency is nothing but the ratio of the frequency to the total number of observations, right?
Yes, sir.
So for any observation, I'm writing in the subscript as I means for the ith observation. So it's nothing but frequency of that observation divided by n means total number of observations. Can I write this?
Yes,
Okay.
sir.
So now, as you see the table, total number of objects. So this is the I can use in these things or these things, right? So basically for this, now what will be the n? N will be fi divided by rfi. Can I write these things or not? Fi means frequency of ith observation and rfi means relative frequency. So what is the frequency here? 300. Okay. And what is the relative frequency for this? 0.3, right? So if you will solve this, what you will get? It's a simple calculation, right?
Yes, sir. 1000.
So 1000 is the correct answer, right? So same thing, you can find out from the here also. I mean, and you can get from here also. 250 divided by 0.25, which will you give again 1000. So 1000 is the correct answer. B is the correct answer. Everyone is got it. So relative frequency is nothing but frequency divided by the total number of observations. That's all. Okay, is this clear?
Yes, sir.
So next question says, what is the value of Z? Okay. So what is the value of Z? So to find the value of Z, what you have to do?
So we can find t first, then we can subtract 1 minus the sum of all.
Correct. So basically, how I can find the value of t first. So for the t, relative frequency is nothing but what is the frequency?
150 divided by 1000.
So basically, relative frequency. So relative frequency is t. So frequency is 150 divided by 1000, right? So if you solve this, I will get 0.15, right? So value of t is 0.15, correct? So value of t is 0.15. Now we are aware about sum of all the relative frequency is what? It should equal to 1, right? So what I can do, sum of all relative frequency means 0.15. That means what? 0.15 plus 0.175 plus G plus 0.25 plus 0.3 equal to 1. So from here I can find out the value of z. So it will be z equal to 1 minus summation of all these things, right? So you can sum up these all values. So it will be 0.15 plus 0.175 plus 0.25 plus 0.3 minus 1. So it will be it's a 0.875 and it will give you 0.125, right? So value of G is 0.125. So option number A is the correct. So far it is clear to everyone.
Yes, sir.
Okay.
Yes, sir.
Tell me, if value of G is 0.125, okay, so what will be the value of Y?
So 125.
125.
125, right? Because relative frequency is 0.125 and we know total number of observations is 1000, right? So from the formula of relative frequency, I can find out the frequency, correct? So relative frequency into total number of observations, I will get 125, right? Now, how I will get the value of X? There are two ways.
Yes, sir.
What is one way
So,
and what is the second?
we can add all the number of x given here.
Correct, correct. And we can find out the from relative frequency also, right?
Yes.
So because we know sum of all the frequency is nothing but equal to total number of observations, right? So far it is clear to everyone? Any doubt? Yes, no?
Yes.
I mean, it's clear, right?
Yes.
Okay. So next question is, there is an analyst, he wants to represent the revenues of the various companies using graphs. Okay. Then which of the following graphical representation is oblique are most appropriate for the purpose, right? So question is, he wants to represent the revenues of various companies using the graphs. Okay. So tell me which option should be the correct. Whether A, a pie chart with a pie or slice of each company and with corresponding to its revenue in crore rupees, or a bar with a bar of each company on the x-axis and the length corresponding to its revenue in crore rupees on the y-axis, or option C, a bar with the bar for each company on the y-axis and length corresponding to its revenue in crore rupees on the x-axis, or D, a bar with the minimum revenue as a baseline. Which option should be correct?
Sir, B.
B. Okay. Anybody else?
B, sir.
B only.
Sir, if it is MSQ, then B and C can both.
Yeah, it's MSQ, right? That's why it's a written representation is oblique R, right? So
Yes,
basically
sir. So then
B and C is correct. Why? So basically bar chart is useful. Yeah, B and C is the correct. Basically, okay. In which scenario I should prefer the bar chart?
Sir, like if we want to know the numbers.
Count of something, right?
Yes, count and numbers.
Basically, when we are interested in count or numbers, right? Then bar chart is more preferable. So here in this question, it's revenues of the company in crore rupees. So let's say, so it's more preferable on the x-axis and the y-axis. So I can, let's say there is company A, B, and C, right? So it's more preferable. I'm using A. Let's say on y-axis, let's say something crore. Let's say 20 crore. Okay. For B, okay, let's say 25 crore. This is 0, and for C, let's say 15 crore. So in such a scenario, so where I'm interested in the numbers, in the count, right? What is the count? What is the revenue of company A, company B, and company C, right? So in such scenario, bar chart is useful. So this is the option B. What option C says? The same thing, nothing, just a change in the axis. I mean, like say they are saying A, B, C here, and let's 10 and 15 crore, 20 crore, like that. So that graph will be like this. That's all. So they are saying like that. Okay. So option B and C is saying like this. So this something, I mean, I can use the bar chart in both ways, no problem. Option number D is saying a bar with the minimum revenue as baseline, so we can't use this one, right? Because in while you are representing the bar chart, so if baseline is the 0, that's a good thing, right? If baseline is not there, that means we will say there is a missing baseline, right? So that chart will not be a good representative of that. Okay. Is this clear? This
Yes, sir.
why we so basically what is the pie chart? We are here, then
It's
okay, before
mostly
going to
used
bar
for
chart, tell me one thing. Suppose I have t-shirt sizes, data set of t-shirt sizes, let's say 15 t-shirts of small sizes, no, 10 t-shirts of medium sizes, and let's say 12 or so let's say 20 t-shirts of large size. Okay, suppose I have this data set. Okay, so suppose I have made the bar chart like this. Okay, this is 0, let's say this is 10, let's say this is let's say this is 5, this is 6. Let me draw it again. Just a minute. So yeah, so suppose this is 0, this is 5, this is 10, this is 15, this is 20. Okay. Suppose I have made the graph like this for medium, this is 10, small, this. So whether it's correct or not. Hello? Whether it's a correct representation or not.
Not,
Why?
we can represent in pie chart.
No, it's a count, right? I'm just saying 15 t-shirt of small size, 10 t-shirts of medium size, 20 t-shirt of large size. Why you should go with the pie chart?
So it's correct, sorry.
So can you tell me, this is the ordinal data, right? Right? I can order the among between sizes of the t-shirt, right? Small, medium, large. Can I order it or not? Right? Yes or no? So whenever you have ordinal data, right? Whenever, so you must preserve the order. Means while you are drawing the bar chart, so you have to preserve the order, means draw first bar for small size, then for medium, then for large, or you can do for large, then medium, then small. So you have to preserve the order. That's the importance of ordinal data set. Okay, it's a good to go with the order of the data set. Is it clear? Yes, no?
Yes, sir.
Okay, so what is the Pareto chart basically? When frequencies are sorted, right? Correct or not? So Pareto chart is nothing but when frequencies are sorted, right? So for example, let's say for company A, revenue is 10 crore. For company B, it's 20 crore, and for company C, let's say for it's 20, let's say it's 10 crore, then 30 crore and 20 crore. So what's the Pareto chart? Suppose someone told you make a Pareto chart, then you have to sort the frequency either in ascending or descending, which you prefer, both are the correct. So sorting means you can plot for first for A, right? Then for C, then for B, right? So this is something meaning of the Pareto chart. So this first for A, suppose this is the 10 crore. Okay. Similarly, then C. Okay. This is suppose 20 crore and one more up to 30 crore. So then B. Okay. So this is the company B. So you have to basically sort. You have to sort the frequency. Either you can do ascending or descending. So this is something for the Pareto chart. Okay. Is this clear to everyone?
Yes.
Okay. So what is the pie chart?
Sir, if we want to know about the share or some share or percentage of something,
Yeah.
then
Basically,
we
pie charts. Yeah, pie charts. It's nothing but circular graph that display percentage of the whole, right? Or yeah, percentage of a whole or share of something, right? Means suppose I have something in 100%, okay, and I want to know what is the share of each slices or each part like that, right? So when we are trying to compare the parts of whole, means we are trying to compare the parts of whole thing, right? Of a whole thing. So let's say an example.
Shareholding of a company.
Shareholding of a
Company.
company, okay.
Of
Anything else?
equity.
So basically, yeah, suppose, okay, let's say, suppose a company A, okay, there is a company A. In that company, there are three kind of items are, I mean, they are manufacturing three kind of items. Let's say, X, Y, and Z, right? So these kind of items they are manufacturing. Suppose owner of the company wants to know, profit of the I mean, after manufacturing these items after a year or in a year, let's say 2020 or 2021, whatever you like. So now pie chart is useful, and he wants to know what is the profit from each item. Okay, so in such scenario, pie chart is useful. I mean, you can make the pie chart, and you will tell like this something. Okay, yeah, I mean like this. You can say 30%. From 30% are profit from after manufacturing the item Y, and 50% profit from after manufacturing the item Z, and remaining 20% from the X. Okay, like that basically. Okay, so something when I want to compare the parts of a whole, I want to know the something percentage of a whole. Correct? Is this okay? This is clear to everyone?
Yes.
So there is one more thing called area principle and all. What is that? Anybody? Area principle. What is the meaning of area principle? So basically, area meaning of the area principle is nothing but the area occupied by a part of the graph should correspond to the amount of data it represents. Meaning of amount of data should represent means, suppose I'm saying suppose this is the 20%, okay, and let's say this is the 30%, and suppose this is the 50%. Okay, so this is the correct, right? I mean, 50% is more than this 30%. I mean, it's representing the amount of data, correct? I mean, area occupied by the part, it's corresponding to the amount of data or not?
Yes, sir.
Okay, suppose I change the something, and I said this is the 30%, this is the 20%, or this is the 50%. Okay, whether it's correct or not?
It's incorrect.
It's incorrect, right? Why is that so?
Because 30 area of the 30% is.
Yeah, because this should be something 20%, right? This is so this 30%, the part of this graph, it's not corresponding to the amount of data, right? It's not like 30%. As you can see, area of the 20% is more than the 30%, correct or not? Right? So it's not a correct graph. And one more thing is called round of error in case of pie chart. So sum of all the slices should be 100%. Okay. Sometimes suppose we are getting, let's say we are getting 29.9% and we are rounding up to 30%. For this, suppose you got no 19.02 or something like that, and you have rounded up to 19%, and this is up to 30%, this is 50%. So if you add the sum of all the things should be 100%. So it should not be more than 100% or not, right? Is this clear? Is any doubt?
Yeah. So
So say there is one more thing called the baseline in case of missing baseline in case of a bar graph actually. So what is that? Suppose you plot the graph. Okay. Suppose this is for A, this is for B. I'm just taking some random data. Okay. And plotting like this. Okay. So suppose this is the 0, this is the 10, this is the 20, like this. Suppose this will be 5, 15, let's say like this. Okay. And one more bar graph I have plotted here. Let's say A, B, C, and this. And this. So this is the 5, 10, 15, 20. So which bar is the good one? This one or the second one? Or what is the wrong or something?
So the last one is wrong because the baseline starts from 5.
5,
is
right?
not
So here
previous.
baseline is missing, right? So it's a meaning, I mean, you can see there is a difference of 5, but there is a difference of 10 like that. But I mean, it's a good to start with the baseline actually. So this kind of graph for the missing baseline. Okay. Okay. So let's move to the next question. Now, which of the following can be defined for both nominal and ordinal data? Okay. So which option should be correct? Mean, median, mode, or all of the above?
median and mode.
Median and mode. Okay. So basically, first of all, we can't find the mean, right? Median is not also correct option for both nominal and ordinal. I will tell you why. So why we cannot find the mean? Because mean is something, it requires some arithmetic operation, right? But nominal and ordinal data is useful for the categorical kind of data, right? Nominal and ordinal we are using for categorical, right? So it's a simply means we can't use the mean. Now come to the median and mode. What is the median? What is the mode basically first? The elements which occur the most frequently, right?
Frequency, yes, sir.
Right? Which have more frequency. And what is the median? Median is nothing but median most observation, right?
Whole data set into 2 parts.
Two
The
parts.
most
Correct.
value.
Now, and to find the median, what is the required first and foremost required? We have to order the observations, right? Now tell me, if your data of nominal scale of measurement, let's say I have data of nominal scale of measurement, let's say female, I have data like this, female, male, female, female, female. Now, male. Tell me, what is the mode? Now, first of all, can you order this? What is the mode? Mode is
F.
F, because it's occurring more frequently, right? More number of times, which is 4 times. Now, can you tell what is the median?
No.
We can't find, right? Why? Because we cannot order. To find the median, what we have to do, we have to first order the things in ascending order, right? So here can I order f less than male, like can we order like this, f less than male like this, something? No, right? We can't. So median is not defined for the nominal kind of data, but median is defined for the ordinal kind of data. Let's say size, t-shirt sizes. Okay. So far so good. Till this example, it's clear why we can't find the median for nominal scale of measurement.
Yes, sir.
Okay. Now come to the t-shirt size example. Let's say I have t-shirt size example like this. S means small, M means medium, right? So large, medium. Now tell me what is the mod?
Small.
S.
S, right?
S.
Because it is occurring more number times, right? Suppose I have added one more L, then mod will be bimodal, right? Two mods, right? Because S is occurring 3 times as well as L is occurring 3 times, right? Clear? So there may
Yes,
be
sir.
2 mods. Let's say, let's continue with one mod. What is the median? So to find the median, can I order this first thing or not? I can order, right? I can do S, then M, L, and L. Right? This is the ascending order. Now, what is the median? Median is the median most observation, or the data point which divides the whole data set into 2 equal parts. So what is the median?
M.
So this M is the median. This is the median most observation, right? This divides the data into 2 equal parts, 3. Okay. So median is M. Okay. Is this clear? So mod is something we can find for nominal as well as ordinal data, while median is defined only for the ordinal data, right? Not nominal data in case of categorical. Is this clear so far?
Yes, sir.
Come to the next question. Yeah. So this is the question. You can say the share of the, I think these things we have discussed, but let's see. The share of Indian telecom market is plotted as the pie chart shown in the following figure. Based on this information, we have to choose the correct option. Okay. So options are saying options. So can you see the chart? Okay. So this telecom company. Okay. So this is nothing but share of Indian. So this yellow part is for the Reliance. Okay. Can you see the numbers inside the chart? This is 37%, and this is for the Airtel, and this is the 27% I'm writing here, and this is for the BSNL, which is 9%, and this is for the Vodafone and plus Idea. Okay, Vodafone plus Idea, which is 27%. Now, so this is the share of this Indian telecom company. So you have to choose the correct option. First is pie chart is not a misleading, pie chart is misleading, pie chart has round of errors, and all that. So which option should be correct? So first of all, let me know, pie chart is not a misleading graph or a misleading graph?
Not a
That is
misleading.
not
And
wrong.
not
Not
a-
misleading, right? Because area occupied corresponding to the numbers, right? So option A should be correct. Pie chart is misleading, so option A and B are contradicting each other. Let's come to the C. Whether pie chart has round of errors or not?
No, sir.
We are okay. So that means B is not correct, C is not correct. So so what is the round of error? Basically, if you are adding the chart, right? We are adding the numbers of the slices, it should come up to 100%. The slice of the pie do not add up to 100%.
No, sir. They add up to 100%.
I don't know. This is also wrong. Mod of the data set is the Reliance Jio.
Yes, sir.
Okay. So basically option A and C, sorry, E is the correct. So basically how will you identify the mod through a chart represent chart given chart. So in case of the pie chart, basically widest slice, no, represents the mod, right? Because mod is what which occur the more frequently, right? Or most higher number of the things. And in case of bar chart, how will you identify the mod? Anybody?
Bigger bar.
Yeah, a bar with bigger length, right? That will represent the mod simply. As you can see here, what is the mod in this case or in this case? Let's okay. Tell me about what is the mod for this chart.
B.
B, right? Because it's occurring more number of times, right? Okay. What is the mod for this pie chart?
Z.
Z. Okay.
Z.
Yeah, great. You are getting the points. Now come to, yeah, this is the one more. The bar chart given in the following figure is misleading. So it's a misleading. You have to give the answer why.
B.
Okay. Anybody else?
C.
See, someone else is saying. Okay. So B is the correct, right? So because baseline is not start at 0. Okay. And what is the meaning of manipulated y-axis? Anybody? Any idea? Meaning of manipulated y-axis? So basically, meaning of manipulated y-axis something. Let me draw a bar chart actually. Okay. So suppose this is x-axis and this is the y-axis. This is some company A, some company B, some company C. Suppose 0 is there. Okay. And let's say 10 is there. Let's say 20 is there. And sudden, let's say 55. Then 75. Okay. So suppose I'm saying, so whether it's manipulated y-axis or not, so it's a manipulated y-axis because you can see initially it was difference of 10 units, right? 0 to 10, 10 to 20. But there is some manipulation has been done. Okay. It's sudden jump to 55. There is some manipulation has been done on the y-axis. So such kind of things we are treating as manipulated y-axis. Okay. Is this idea, is this clear somewhat?
Yes.
Okay. And suppose I'm mentioning like this. Let me erase these things. Okay. Suppose I'm mentioning like this. Just a now, whether it's a manipulative y-axis or not. If graph is represented like so, whether it will be manipulated y-axis or not.
No, sir. It's correct.
Why?
Sir, because the intervals are equal.
But it's a 0 to 20. Okay, suppose this is not 20. Let's say this is the this is let's say 30. This is 40. This is now.
So now also it's correct because there's the line in between.
Correct. So it's not a manipulated y-axis because I have mentioned the break. I'm saying it start with 0. There is some break and then it starts 20, 30, 60 and 20, 30, 40 and 50 and so on. So if the break is not mentioned, okay, that so if break is not mentioned, then that means they have done some manipulation on the y-axis, but they are not telling us, or they are not representing that manipulation. Okay, if break is not there, that means it's a manipulated y. Okay, is this clear? Any till now? Yes, no?
Yes, please.
Okay, so I think we have covered all the concepts of till week 2, right? Okay, so let's move to the concepts of week 3. Okay. So now I don't have questions for the week 3. I will discuss the concept along with some by taking some examples. Okay. Now, so we have discussed something variable and data set, right? So how many kinds of variable? Two things. What are the first?
Categorical and numerical.
First is the categorical and second is the numerical data, right? And for the numerical, we have two types. What are those? Anybody?
Ratio and interval.
No, that's a scale of measurement. I'm talking about inside the numerical variable, we have two kind of data set.
Okay.
Have you heard about discrete and continuous?
Yes, sir.
Yes, sir.
Okay. So that was the scale of measurement, right? So numerical data has two types, discrete data and continuous data. So what is the discrete basically? So discrete is nothing but something, it's a countable. Okay. We can count. For example, let's say I'm saying number of people in a house. So it will be discrete. You can count, right? 1 people, 2 people, 3 people and all, right? And another example, let's say number of accident, on a road, something like that in a particular city. So you can count, right? 2 accident, 4 accident, 0 accident, like that, right? It's a countable. Basically, one more thing I can say, it takes distinct value on real number line. So it takes distinct value on real line means, suppose you drawing the real line. So it will take, let's say 1 accident, 2 accident, 3. It taking distinct value, right? It cannot take any value in between these values. Can it take? It can't take like any value between 2 and 3, any value between 3 and 4, any value between 1 and 2, right? It can't take, right? Suppose I'm saying number of people, you can't say 1.5 people or 2.3 people or 2.33, 2.42, something like that. So it is taking distinct value on real number line. This is the one thing. Another thing, important thing, it's a countable. Idea is okay?
Yes, sir.
Okay, what is the continuous data?
So there will always be a value in between two numbers, or like
Okay. What
1
is the
and
main-
2,
main-
there can
main
be
key thing?
1.2.
That's the one thing. What is the main thing to identify whether it's a continuous or not? So
It can have
basically
a decimal
continuous,
value.
yeah, it's not countable. We can't count. Key thing is, for to identify the continuous, it involves measurement of something, basically. So it involves the measurement of something, and it can take any value between the interval. So what is the meaning of measurement of something? Let's say I'm saying, tell me height of a person. So whether height of a person, you have to count or you have to measure.
Measure.
Yeah, we have to measure in feet or centimeter, like that, right? You can't count the height. You have to measure the height of person. Let's say weight of a person, then Whether you have to count or measure?
Measure.
Measure. You have to measure the weight in kilogram, right? Another example, you can say speed of a vehicle. Tell me, you have to count or you have to measure?
Measure.
Measure, right? In measure in kilogram, not kilogram, kilometer per hour, right? So I'm taking one or two examples. Let me know whether it's discrete or continuous. Okay. Let's say number of attempts, no, to clear an exam. Whether it's a discrete or continuous?
Discrete.
It's a discrete, right? I mean, a number of attempts. So let's say one attempt, two attempt, or three attempts, right? Tell me another thing. Time taken by a student to complete an exam. Now,
Continuous.
continuous, right? Why continuous? It's not a something you can count first thing, and it can take, suppose exam is of 3 hours, so student can take any value from 0 hours to 3 hours, right? It can take 1 hour, 15 minutes, 20 seconds, something like that. Correct or not? So key
Yes, sir.
thing to distinguish between discrete and continuous is nothing but continuous is something which you cannot count, you have to measure, and discrete is something you can count. Okay, and continuous, it can take any value between a given interval. Okay, so far it is clear.
Yes, sir.
So there is one more thing in this week called stem and leaf plot actually. Okay, you are familiar with the histogram, right? Okay. So basically histogram, in histogram there are some things, basically there are some class intervals which are represented by like this. So this is called the basically lower limit, and this is called the upper limit actually. Okay. And similarly class width. So class width is nothing but difference, and and what is the class mark? Class mark is nothing but average of these two value like that. Okay. So these are some basic thing. Basically histogram is more popular or most popular graphical representation for the basically continuous data, because for the discrete data I can simply draw the I can simply plot the bar chart. So another thing is called stem and leaf plot. Okay. So what is this? Basically, there is some interpretation. I mean, this in the stem and leaf plot, each observation is separated into two parts. First part is called stem, and second part is called plot. Sorry, not plot. It's called leaf. Stem and leaf plot. So basically, I mean, there is one thing, key is provided. What is the meaning of key? Suppose I'm writing like this, okay? So I'm writing 7, 5, okay? And then suppose I'm writing the key means I can write 7, 5 means 75. So I had observation 75, and I have separated this 75 in two parts, 7 and 5, okay? So this is the meaning. I mean, if in one part is 7 and another is in 5, that means 75. Suppose I have written comma 8. What is meaning of that? There are two observations, 75 and 78. Are you getting? Suppose next I have written 8, 0, 2. So what are the observations here? 75, right? This is okay. I have provided the key. Key means 7, 5 here. I have represented how we are going to interpret. Suppose 7 given, not given, it's I separated in two parts. This means 75. That means I have observations 75, then 78 and 80 and 82. So we have these four observations. Is this okay? Are you getting?
Yes, sir.
Okay. So key can be anything, right? This not important. So according to key, you can interpret. One more important thing, as you observe from here, these observations are already in ascending order. So in stem and leaf plot, your observations will be in ascending order actually. Okay. Is this clear?
So I have a question.
Yeah. Please go ahead.
Yeah, like if the number is of 3 or 4 digits, like 104 kind of
Okay.
something.
Yeah, so based on that, key will be provided. Like suppose I'm saying, let's say 128, and I said key is 1 2, it means 128. Okay, so key will be provided. What is the how we are going to interpret? Okay, so it will be like that. Your stem will be like that stem. So it will be 128, comma 9. Let's say 1 3 2 3. So what are the observations you are based on the key 128, 129, 132, 133, right? Clear?
Yes.
So key will be provided, don't worry. Suppose, okay, one more, let me ask one question to all of you. Suppose I've written 7, 2, 3, 9, then 8, then let's say 9, 0, 3. So tell me the observations. What all are observations? So key is 7 given to me 72. So what all are observations here?
So 72, 73, 79,
Okay.
90, 92, 93.
Right. So there is missing leaf for 8, right? So there is not any observation for 8. We can't say it's 80, right? We can't say. That means it's simply means there is missing observations from 0 to 80 to 89. There is not any observation from 80 to 89. Okay. So stem and leaf will be should be given to you. Okay, is this clear? Now come to the next topic. Okay, so far so good. Everyone got the idea?
Yes.
So one important thing called the measure of central tendency. Okay, what is the meaning of measure of central tendency? Basically, suppose you have data set, right? So is the suppose you want to represent your data set or you want to say something about your data set. So suppose you have marks. Let's create a situation of marks of the students in a class and whatever. So how we are going to tell about my data set, right? Suppose I have let's say 50 students in my class, and I want to tell some information about marks of the student. So it's good to go to tell all the marks of the students, marks of all the students. Let's say marks of first student is 92, then 72, then 27, then 58, like that. Should we go like that, or there should be any other agenda or any other criteria to give information about something, in a one number about the class, about the marks of the class? Is there anything else we can go? So that way is called central tendency. Suppose rather than telling all the observation or something like that, it's good to give a give the idea about something central value. What's the central idea about my data set, right? So suppose I'm saying average marks of the class is 70, then you will have some idea. Students are okay, students are good in history, like that, right? So you have to find the central idea. Now to know the central idea, central point, so there are some measures. Okay, what are those? So first is called mod, then median, then mean. These all are things known as the measures of central tendency. Okay, because see, mod is something. Suppose you told the most. Okay, suppose the maximum students got 72. You can say mod of the marks of that class is 72. Then you will have some idea. Yeah, for that class students are good, maximum student got 72 marks. Let's say median. So median is what? Median represents something, it divides the data points into two equal parts, right? So basically, suppose you are saying median marks is let's say 82. So that means that what is the meaning of 82? So that means 50% of the students are less than 82 and remaining 50% of students are more than 82. Mean is nothing but just a simple to finding the average. So average is nothing but sum of all the observation divided by total number, right? So mean is you can simply find the what is the average marks of the class. Okay. So is this okay to so far? Median mean. So median, okay. So for median, what we have to do? We have to first arrange the data in ascending order. Then we have to identify, since it's a numerical data, so we have to identify the n. N means number of observations. Okay. So whether it's even or odd. Okay. Because if the number of observation is odd, so median will be what? So it's a simple thing. So median will be no, it's nothing but mean of n by 2th observation. Okay, and n by 2 plus 1th observation. Okay, if n is even. If n is odd, then median is n plus 1 by 2th observation of that arranged data set. For example, let's say your data set 2, 1, 3, 5, 4. Okay. So what is the first we have to arrange in data ascending order, right? So what it will be? It will be 1, 2, 3, 4, and 5. Correct. So n is what? Odd. N is total 5 observation, right? 1, 2, 3, 4, 5. Correct. So if n is odd, then what is the median? Median is nothing but n plus 1 by 2th observation. So n is 5 plus 1 by 2th observation. That means 6 by 2. That means third observation. So what is third observation? 3. So 3 is the median of this particular data set. Okay. Suppose you have one more observation. Let's say 16. Okay. So what will be the ascending order? It will be 1, 2, 3, 4, 5, 16. So n is even, right? How many observations we have in total? 6. 1, 2, 3, 4, 5, 16. So total we have 6 observations. 1, 2, 3, 4, 5, and 6. So for this, we have to find the average of the two middle observations. That means n by 2th observation. So n by 2th observation is what? 6 by 2th. That means third observation. What is the third observation? This 3. And what is the n by 2 plus 1th observation? That means fourth observation. So what is fourth observation? Is 4. So we have to take the average of these two. So 3 plus 4 divided by 2. So 3.5 will be the median of this data. Okay, is this clear? Is this okay to everyone? And what is the mean?
Yes.
Mean is nothing but addition of all the observation divided by number of holes. That means 1 plus 2 plus 3 plus 4 plus 5 divided by 5. So it will be 5, 4, 9, 10, 15 by 5, which is 3. Okay, this is something called, something we can compute the mean and all. So there is something called extreme value. Sensitive to outliers. Suppose I have observation 1, 2, 3, 4. Let's see. Let's say. Okay, for 5, what is the median? Median is 3.
3.
And what is the mean? Mean is also 3. 15 by 5, which is 3. Correct? Now, instead of this, suppose I've taken the data set 1, 2, 3, 4. Instead of 5, suppose you have 500. Okay. So what will be the median?
3.
3.
And what is the mean? So it will be 5, 10. 510 divided by 5.
102.
Right? So 102. So can you see this due to this extreme value 500, right? So initially for the old data set, median was 3, mean was 3, but due to an extreme value, due to an outlier, mean got changed, right? Mean got significantly changed, right? Correct or not? It's about 3 and then 1, not 2. But median is same. Or it will be changed, but somewhat. So can I say mean is sensitive to outliers? Right?
Yes, sir.
Because it's got significantly changed. And median is not sensitive to outliers. Okay. So this is the one information. And another concept is called, addition and, adding a constant and multiplying a constant to the old observation and all. So basically what that thing is, suppose okay, so you have session from 8 p.m., right?
Yes, sir.
Okay. Okay, so let's discuss that one concept. Okay. And after that, you can go for the Python session, right? Is there? Okay. So let's discuss this thing.
Yes.
Suppose I had data says 1, 2, 3, 4, 5, right? And median was 3 and mean was 3 also, right? 15 divided by 5, right? So now tell me, suppose I want to add a constant 2 to this observation. So what will be my new data set? If I want to add 2 to all the observations, what I will get? 2, not 2, I will get 3, 4, 5, 6, 7, correct or not? If I want to add 2 to these all the observations, I will get this data set as new data set, correct or not? So tell me, let's say one more 5 is there. Okay, forgettable. So what is the median? What is the median of this new data set? 5. Hello. What is the median of this new data set?
5, sir, 5.
It's a 5, right? And what is the mean? If you compute, so 3 plus 4, 7, 5, 12, 6,
12.5.
18, 25 divided by 5, which is again 5, right? So can I say median is 5? So what is the old median? Old median is 3 plus this constant. What is the old mean? Is 3 plus this constant. So can I say, if I want to add a constant to all the observation, then my new median of, median of new data set will be old median plus that constant value or not? Correct? Same for, I can say new mean is same as old mean plus that constant. Would you agree with me? So this is the old mean 3 and this is the old median plus that constant. Is it okay? Yes, no?
No, sir. Actually, for median, like based on the numbers which are present, we can find the median.
Sorry, can you repeat?
Yeah, based on the sequence of numbers, right? 3, 4, 5, 6, 7, and we are adding 2, right? To the
Yeah, we are adding 2 to all the observations.
Oh, okay, okay then.
Okay, so
yeah,
why? Okay, this is the one of the property, because suppose you have data set of 100 people or 200 people, okay, and
okay.
it says of that 100 people median is something, okay.
Yeah.
And suppose, okay, let's say that data set is about marks of the student, and suppose for one question, due to some something wrong in one question, class teacher wants to give wants to add 3 marks to all the students, right?
Yeah.
So you know the average. Suppose you know the average marks of the previous data set.
Oh, yeah.
So what it's a good to which will be good whether you are going to add 2 to all the observations, then you are computing the average value, or you can directly apply this property, right? You know, suppose average marks of those I mean initial 100 students is 72, and you know 2 is going to add to all the marks of all the students. So you can simply tell new median will be 74. That's all.
Yeah, okay. I actually misunderstood you are like adding 2 to the sequence of the numbers.
No.
So yeah.
Okay.
Yeah, okay.
So
Yeah.
similarly, suppose I want to multiply some, let's say I had observations like this. Okay. I want to multiply the constant, let's say 3. What will be my new data? So before this, what is the median? Median is 3, mean is 3 for this old data set, right?
Yeah.
Now, if I want to multiply constant 3, then what I will get? I will get 3, 6, 9, 12, 15,
Yeah.
right? Now
Yeah.
tell me what is the median for this new data set?
It's
Or
9.
you can say new median, it's a 9, right?
Yeah.
So this 9 is same as
3 plus 3. 3
3 into 3, right?
3 into 3, yeah. Actually,
So okay,
multiplying,
what
yeah.
is this 3? This is old median into that constant.
Yeah, okay.
Can I say?
Based on the operation we are performing, like we have to.
Yes, we can apply for that. Now, what is the mean? What will the mean? Mean will be something, 3, 6, 9, 9, 18, 12, 30, 45 divided by 5, right? So again 9, correct?
Yeah.
So what is this new mean? New mean is 9, and this new mean is nothing but, can I say, 3 times 3?
Yeah.
So this 3 is nothing but value of old mean into the constant value.
Yeah.
Correct? So this 3, let me use another color. So this is the old mean, and this blue color is simply. So I can simply say if I want to multiply by a constant, or I want to add by a constant. So new median will be old median into C, and new mean will be old mean into C. Similarly, if you want to add, then it will be new median will be old median plus C, new mean will be old mean plus C, and same concept will be applied for mod also. So it will be new mod of your new data set will be old mod plus C, and if you want to multiply, it will be new mod will be old mod into C. Okay, is it clear so far?
Yes, sir.
Okay, so I'm stopping here because you guys have one more session. Otherwise, we can continue. So we'll discuss the remaining topics from in the next session. Okay, will that be okay?
Yes, sir.
Okay. Then thanks, guys. I hope you got the concept so far. We'll discuss the rest of this. Okay.
So will this video be available later?
Yeah, it's already on YouTube, right? It's
Okay.
already, yeah, you can rewatch on the YouTube also.
Can we get this PDF also?
Okay, I will which question one, or the has been written by me?
Will be the PDF if we want to go back and practice it.
Okay, no problem. I will share with the team. They will upload or they will mail.
Thank you.
Oh,
Thank you so much.
yeah, thanks. Thanks everyone. Bye.
Thank you.
Yeah.
Thanks, sir.
Very much.